Thank you for reviewing my project. I am writing an article that explains the relationship between gasoline and carbon dioxide for Science Teacher magazine. This lesson is targeted for grades 11 and 12. The relationship is an important one that receives little exposure. When we use gasoline in our cars, 96% becomes part of the natural carbon cycle, but 4% is an imbalance that builds up over time. Let's take a look how using gasoline produces carbon dioxide. We want our students to take away that a gallon of gasoline produces 20 pounds of carbon dioxide. That 20 pounds of carbon dioxide has a volume of about 175 cubic feet, or a cube with sides of 5'7". In the U.S. alone, we used about 142 billion gallons of gasoline in 2019. This produced 2.84 trillion pounds of carbon dioxide. If we want to attack that 4% imbalance, this is a good place to start. Now that we have a picture of how big the problem is just from gasoline and transportation, let's take a look at the chemistry. The chemical equation is fairly straightforward. Just to balance, you're basically breaking apart carbon compounds, building blocks, and then combining with oxygen to give you H2O and carbon dioxide. In the example here, I had my students do it with models, just little red stickers that would allow them to balance the equation visually. Now that we understand some things about the chemistry, let's focus on how to get to the 20 pounds. First, you start with a carbon atom, which has an AMU of 12. You combine it with two oxygen atoms, which have AMUs of 16. This produces CO2. That molecule has an AMU of 44. This ratio of 44 over 12 is used by the EPA as the multiplier for CO2 during combustion. Here's the example worked for you at 6.3 times 0.87 times 44 over 12 gives you 20 pounds. Now that we've covered the science, let's take a look at the lesson plan and lesson planning as I approached it. My focus was on integration. I think I've learned in the program that the definition of STEM is integration. You constantly have to be weaving these parts together to really make STEM work. You can study the kind of layout of my integration matrix there, or if you want to see the entire one, just click on the link. Continuing the planning process, the next area that I went to was the three-dimensional learning aspect. As you can see in the chart here, I tied the cross-cutting concepts and practices to the disciplinary core ideas. And to follow that up, on the right-hand side, you'll see there's assessment that goes with each one of those. As before, you can either study this example or follow the link, and you'll see the actual one I completed. This is the final activity for the lesson, and it shows the products of the combustion. Liquid gasoline is converted to water vapor and CO2 gas. The two products of combustion are shown in the 5'7" cube, which represents the volume of CO2 produced by 1 gallon of gasoline. At the very bottom, you'll see the 20-pound weight. Students like to compare that to the 6.3 pounds of gasoline that produced it. Balancing chemical reactions with removable stickers was the most popular lesson. They added they wished they would have learned this way in chemistry class. Building a spreadsheet was the most difficult activity. Some had not done a spreadsheet since the 8th grade. The unit focus, 1 gallon of gasoline produces 20 pounds of carbon dioxide, was covered on the 4th day. And there was immediate chatter about making unnecessary trips and that the students didn't want to be the one who, quote, killed the environment. The final PVC model was fun and they were proud of the results. This is the list of my top references. As I mentioned in the beginning, there is knowledge about this. A gallon of gasoline equals 20 pounds of CO2. There are articles on the internet, but there's no real lessons to teach it. That's the part that I selected. I think it will be a unique lesson and hopefully will be published. Thank you very much. I appreciate your feedback.